next zone of our planet is sort of this middle zone known as the mantle. And as I said, that the mantle has two zones, a lithosphere and an asthenosphere. And it is in the asthenosphere where all the action happens, where everything that really is going to make up the surface of our Earth is generated from. So this is a zone that has a hotter zone and a lower, cooler zone. So if it's logical that this is the hottest part of our planet and it's cooler as we move towards the edge, within the asthenosphere, which is this zone right here, it's hottest here and cooler here, and then on the lithosphere, hotter here and cooler here. So in this zone we have this bumpy, uneven textured environment, and I want you to think of why it might be bumpy. And with a thought experiment, I want you to make 2 pans of Jello. Put them both in the refrigerator, and an hour later I want you to take one out and stir it. Put it back. An hour later I want you to take that same pan that you stirred, bring it out, stir it again. And I want you to do that over the course of an evening. And then the next morning, what is that stirred pan of Jello going to look like relative to the flat pan of Jello that you didn't touch? I hope what you're going to imagine is just a mess. It looks all bumpy and ragged, it's solidified, but it looks torn apart, and there's chunks, and it's sort of uneven, and there's just bits everywhere. That's kind of what the mantle looks like, because the mantle is being stirred by two forces. It's being stirred by the rotation of our planet, but it's also being stirred by convective currents. So just like we've got convective currents on the surface of our Earth that are rotating the atmosphere, the hottest part of our atmosphere is down here. It is cooler as we move out. Same thing's happening here. So we're going to get matter that's hot. It's going to lift and it's going to fall and lift and fall. So in this, as it cools up here and solidifies as rock or stone, it's going to come down here, and as it's moving, it's going to get just torn away from other rock, and then chunks and bits are going to be pushed back into the surface of the lower parts of the asthenosphere down to this margin here, which is warm. It's going to constitute into this more plastique mass through radioactive decay. So basically what we're doing is we're taking whatever the configuration of the rock is here, and it's like the recycle zone of our planet. So if we've got lots of aluminum and other metals here, we're going to put them all into this big furnace and create new magma and push it back up here where it's going to form solid rock again. So this is this bumpy, uneven textured zone because of convective currents that are pulling things apart and breaking them up and reforming them in the asthenosphere on the upper edge of the lithosphere. So I use the term radioactive decay. What is happening is those rocks, which are solid, are going to be constituted back into their elemental forms at this zone here through this convective condition. We also have isostatic response here. So now you've made 2 pans of Jello, right? And you've taken a look at the really cranky looking Jello that's all rumply and crazy looking, and you've got a flat pan of Jello. In that flat pan of Jello, I want you to take your hand and gently lay it on the top of the Jello, rest it on the top. What you'll find is that the Jello is going to support your hand, but it's going to depress a little bit. So it's going to rebound into the Jello a little bit. And just like high and low pressure zones of the atmosphere, we're going to press in a little bit and provide a little force where the hand is. But there's going to be a low pressure zone on either side of your hand, so the Jello is going to lift. So the lithosphere and asthenosphere are a lot like the Jello, where you've got lots of mass, a continent. You're going to have depression. Where there isn't a continent, you're going to have some lifting happening as well. Depending on the volume of mass that you have, you're going to sink further with more mass and be a little bit higher with less mass. And the volume of mass on continents changes over time. due to continental construction. We're adding matter based on continental collisions or volcanism, and you're always taking matter away with erosive forces and weathering. So we're going to move matter off. The continent's going to become less heavy, and it's going to lift. When you add matter, it's going to sink a little bit deeper. Same thing happened with ice ages. When you add ice to a landmass, it's going to sink a little bit further into the asthenosphere. When that ice melts away, the continent lifts a little bit higher. And with the Laurentide ice sheet, which was the last ice mass in North America with the last glacial maximum, we saw a lot. We're seeing a lot of rebounding back up. The last little bits to rebound back up are our Great Lakes, in fact.